Hi, this is Dr. Naga Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about polymers. What are the polymers and what are the types of polymers and classification of polymers. So, polymer is a macromolecule. The polymer is essentially is a combination of many subunits. The term polymer in Greek means many parts, and polymers can be found or alone as. So poly means number of, mass means repeating units. So number of repeating units are joined together form a macromolecule that is known as polymer. From the standard of our DNA, which is a natural occurring biopolymer, to polypyrene, which is used throughout the world as plastic. Polymers may be naturally found in plants and animals or may be man-made polymers. So natural polymers are which are obtained from naturally. So whereas synthetic polymers are nothing but man-made polymers. Different polymers have a number of unique physical and chemical properties due to which they find usage in everyday life. Coming to the definition of polymer. Polymer is a macromolecule or big molecule which is formed by the combination of simple molecules. These simple molecules are known as monomers. These monomers either same or different depending on type of reactions. Polymer is a macromolecule which is formed by the micromolecules. Number of micromolecules are combined to form macromolecule. These micromolecules are known as monomers. These monomers either same or different. So that is the definition of polymer. Coming to the classification, we can classify polymers on the basis of several factors. Why? Because polymers cannot be classified under one category because of their complex structure, different behavior, and vast of applications. So we can therefore classify polymers based on following considerations. So let us see the first type of classification, which is based on source of availability. On the basis of source of availability, polymers are classified into three types. That is natural polymers, synthetic polymers, and semi-synthetic polymers. So let us see one by one. First, natural polymer. Natural polymers occurs naturally and they are found in plants and animals. For example, if you take proteins, so protein is the natural occurring polymer. Protein is formed by the nothing but building blocks of amino acids. So different types of number of amino acids are combined to form protein. Next, starch. So starch is nothing but carbohydrate, polysaccharide. It is a type of carbohydrates. So starch is formed by the combination of different monosaccharides units. Starch is usually it is a polysaccharide and cellulose. Cellulose is also natural occurring polymer and rubber. Here we can say that we can take rubber example for natural polymer as well as synthetic polymers. Why? Because isoprene is the natural occurring rubber. Number of isoprene units are combined to form natural rubber. So, what is the isoprene? 1,3 butadiene. 2-methyl 1,3 butadiene is known as isoprene. 2-methyl 1,3 butadiene is the isoprene. So number of isoprene units are combined to form natural rubber. Whereas rubber also can be obtained by the synthetic polymerization reactions. For example, if you take SBR, styrene butadiene rubber. So it is formed by the synthetic polymerization of styrene 1,3 butadiene. Styrene butadiene rubber SBR. That is a synthetic rubber. It is prepared by the synthetic polymerization of 1,3 butadiene plus styrene. So what is a styrene? Vinyl benzene. So that's why we can take rubber as an example for both natural occurring polymers and synthetic polymers. Coming to the semi-synthetic polymers. They are derived from natural occurring polymers and undergoes further chemical modifications. So those polymers which can mold into by the addition of certain chemicals. There is a possibility of chemical modification that is known as semi-synthetic polymers. For example, cellulose nitrate and cellulose acetate. Here, cellulose is a natural polymer, but we are going to add nitrate to cellulose. When you add nitrate to the cellulose, some chemical modification takes place. Similarly, cellulose acetate. Here cellulose is the natural polymer here also. So when you add acetate to the cellulose, some chemical modification will occur. So that's why cellulose nitrate and cellulose acetates considered an example for semi-synthetic polymers. So semi-synthetic polymers are nothing but those natural polymers in which chemical modification takes place by the addition of certain chemicals. Whereas, and third one is synthetic polymers. So these polymers are pure man-made polymers. Why? Because these are formed by the polymerization reactions in laboratory. For example, plastic. Plastic is the most common and widely used synthetic polymer. It is used in industries and various dairy products. Nylon 66. Examples for synthetic polymers are nylon 66, polyethers, PVC, bacrate, etc. etc. So this classification based on source of availability. So on the basis of source of availability, there are three types of polymers, that is natural polymers, synthetic polymers and semi-synthetic polymers. So natural polymers are obtained from directly from nature. Semi-synthetic polymers are, so there is a chemical modification of natural polymers by the addition of certain chemicals. Whereas synthetic polymers are pure man-made polymers. Next type of classification is based on structure of the monomers. So on the basis of structure of the monomers involved in the polymerization reaction, polymers are classified into linear polymers, branch chained polymers. So linear polymers. The structure of polymers containing long and straight chains monomers comes under this category. For example, if you take PVC, polyvinyl chloride, is largely used for making pipes and electrical cables. An example of linear polymers. So PVC is the polyvinyl chloride. Here monomer is vinyl chloride. So if you see the structure of vinyl chloride, CH2, double bond CH, Cl. So number of vinyl chloride molecules are combined and undergoes polymerization to form PVC. So if you see the structure of vinyl chloride, a linear chain is there. So there is no branching of chain. So this is the example for linear polymers. And next one is branched chain polymers. When linear chains of polymers forms branches, then such polymers are categorized as branched chain polymers. For example, low density polythene. And third one is cross-linked polymers. So in this type of polymers, we can observe cross-linkage in between the monomeric units. That means these are composed by bifunctional and trifunctional monomers. So they have stronger covalent bond in comparison to other linear polymers. So best example for cross-linked polymer is bakelite. So if you see the structure of bakelite, cross-linkage we can observe. So this is the cross-linkage. So this type of linkage we can observe in between the monomeric units. So if you take bakelite, monomers in bakelite are phenol formaldehyde. So we can observe this type of linkage in between the phenol and formaldehyde monomers. So here there is a cross linkage in between the monomeric units. And next type of classification, which is based on types of polymerization reaction. So on the basis of polymerization reactions, polymers are classified into two types, that is additional polymerization or additional polymers, condensation polymers or condensation polymerization. So in additional polymerization or additional polymers are formed by the combination of monomers which are same or different without elimination of simple molecules. That is known as additional polymers, and this phenomenon is known as additional polymerization. So example for additional polymers are polythene, Teflon, polyvinyl chloride, etc. So during polymerization reaction, in additional type of polymerization, there is no elimination of simple molecules. In most of the polymerization reactions, water will be eliminated as a byproduct. But in case of additional polymerization, so there is no elimination of simple molecules. So that is the additional polymers and additional polymerization reactions. Whereas in condensation polymerization reaction, a polymer is formed by the combination of simple molecules which are same or different with elimination of micromolecules or byproducts. So in most of the cases, water molecule will be eliminated in condensation polymerization reactions. So example for condensation polymerization reaction is nylon 6,6, bakelite, and peridine and polyesters. So the key difference in between the addition and condensation polymerization reaction is elimination of byproduct. In additional polymerization, there is no elimination of simple molecules, that is water molecule. In condensation polymerization, water molecule will be eliminated as a byproduct. So that is a major difference between the additional polymer or additional polymerization and condensation polymerization reactions. Next type of polymerization reaction, polymerization classification. So based on monomers. So on the basis of types of monomers, polymers are classified into homopolymers, heteropolymers. In homopolymers, only one type of monomers are involved in the polymerization reactions. Only one type of monomers involves in the polymerization reactions. For example, if you take polythene or PVC. For example, if you take PVC, polyvinyl chloride, so here monomer is vinyl chloride. Vinyl chloride. Here only one monomer involved in the polymerization reaction, that is vinyl chloride. Only one type of monomers involved in the reaction. Whereas, if you take heteropolymers, heteropolymers are also known as copolymer, and this polymerization reaction is known as copolymerization. Here, different monomers are involved in the polymerization reaction. For example, if you take nylon 66. So nylon 66 is formed by the polymerization of adipic acid and hexamethylene diamine. Adipic acid and hexamethylene diamine. Hexamethylene diamine. So these two monomers are different to each other with respect to structure, with respect to properties. These two monomers are different to each other. So this type of polymerization is known as copolymerization or heteropolymerization, and that polymer is known as heteropolymer and copolymer. Why? Because here different types of monomers undergoes polymerization reaction. Next type of classification based on molecular forces. On the basis of molecular forces which is involved in between the monomeric units, polymers are classified into following types. That is elastomers. These are rubber-like solid, weak interaction forces are present in between the monomeric units. Example, rubber. Fibers. Strong, tough and high tensile strength and strong forces of interaction present in between the monomeric units. So example for fibers is nylon 66. And next one is thermoplastics. So they have intermediate force of attraction in between the monomeric units. Polyvinyl chloride. Example for thermoplastics are PVC. And next one is thermosetting polymers. These polymers greatly improve the material's mechanical properties. It provides enhanced chemical and heat resistance. Example, phenolics, epoxies and silicones. So this classification is based on type of molecular forces which are involved in between the monomeric units during polymerization reaction. Next classification on the basis of carbon chain. So on the basis of carbon chain, we can classify the polymers into organic polymers and inorganic polymers. In organic polymers, the backbone in monomers it should be carbon. Example, PVC, polythene, bakelite, etc. etc. Whereas in inorganic polymers, there is no carbon in backbone. That carbon is replaced by other elements. So that is known as inorganic polymers. So example for inorganic polymers are polystyrene. So in polystyrene, silicon bonds we can observe as say this type of bonds. Silicon to silicon bonds we can observe. And polysiloxanes. So in polysiloxanes we can observe silicon to oxygen bonds. Next, polysiloxanes. In polysiloxanes we can observe silicon to nitrogen bonds. And next one is polysulfide. In polysulfide we can observe sulfur to sulfur bonds. And next one is polyphosphagens. In polyphosphagens we can observe phosphorus to nitrogen bonds. And last one is polybologyrenes. In polybologyrenes we can observe boron to nitrogen bonds. So if you see the entire these compounds, there is no carbon. There is no bond present between the carbon. Here different types of elements present in monomeric units. And bonding also takes place in between the different elements but not carbon. That's why we can say that in inorganic polymers there is no carbon in backbone chain of monomers. So this classification based on backbone of the monomers. And next type of classification is on the basis of their synthesis. Depends on the synthesis, polymers are again classified into natural polymers and synthetic polymers. So in natural polymers, there is no particular synthesis. Natural polymers are synthesized by natural procedure. For example, if you take rubber, natural rubber, that is a isoprene. So there is no particular chemical reaction or chemical procedure to synthesize isoprene units. So it is prepared by or it is obtained by rubber tree, direct tree. And next one is synthetic polymers. So for synthesis, to synthesize synthetic polymers, there is a separate synthetic procedure or chemical procedure is available. For example, if you take PVC, polyvinyl chloride. So to synthesize polyvinyl chloride, here some particular polymerization reaction is there. So vinyl chloride undergoes polymerization reaction produce PVC. So there is a specific chemical procedure for to synthesize PVC. So this type of polymers are known as synthetic polymers. So on the basis of synthesis of polymers, polymers are classified into two types: natural polymers and synthetic polymers. And next type of classification is on the basis of degradation. So here, what is the degradation? It is nothing but decay of material by the attack of microorganisms. So breakdown of the polymers by the attack of microorganisms, nothing but degradation. So this type of polymers are known as biodegradable polymers. So those polymers which are degraded by microorganisms like bacteria are known as biodegradable polymers. So these type of polymers are used in surgical bandages, capsule coatings, and in surgery. So example for biodegradable polymer is well-known example, that is polyhydroxybutyrate coval. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.